In this section, section 10.2, we're going to begin some of our geometry work, and we're going to spend a little time talking about similar triangles. And although we're going to focus on similar triangles, the concept of similarity of figures will be consistent. Take a look at these two triangles. They are obviously not identical, they're not the same size, but because their angles, their corresponding angles, are congruent or equivalent in measure, that means that the triangles have the same shape. And what is also true is that the corresponding parts are proportional. And by proportional means that you could write a true proportion. For example, 6 is to 3 as 8 is to 4. And that's a true statement. I could even extend it as 4 is to 2. Each one of these ratios is equal. Now, when we deal with proportions, we're not going to have 3 ratios, we're just going to have 2. Oops. But there are many ways that you could set up a proportion. I am going to always work with corresponding parts. So I would be taking the 6 side and putting it with the 3 side over here, and the 8 with the 4 with the 2. So you'll see that as I go through this. Then we're going to use our technique for solving proportions, which is cross products. Let's take a look at this first problem. And let me see if I can get a little extra space. All right. It says use similar triangles to solve. A person who is 6 feet tall is standing 117 feet from the base of a tree. And the tree casts a shadow, this is its full shadow down here, 130, I'm sorry. The person's shadow is 13 feet. What is the height of the tree? Now, although you might not see it at first, there are 2 triangles here, and they are similar. One of them, and forgive my drawing here, but one of them is the triangle formed, that's really bad, by the tree. The other one, which is a similar triangle, is formed, and mine are not truly similar, but you're supposed to use your good imagination. It's formed by the man. Now let's transfer the numbers. The height of the tree is what we're looking for, so I'll put an X there. The shadow cast by the tree, and it says it up here, is 130 feet. So it's 117 till it gets to the man, and 13 more. That is 130 feet. The man's shadow is 13 feet, and his height is 6 feet. These are proportional, so I'm going to write down the proportion. I'm going to say X is to 6 as 130 is to 13. So I like to do corresponding parts. There are other ways you could do it. This is the way I want to do it. All right, I'm going to solve it with a 2-step approach. I'm going to do the cross product. 6 times 130, and you can do that off screen. That is 780. Step 2, take your 780, divide it by the number you haven't used yet, which is 13. Once again, I'm going to do that on my calculator off screen, and I get 60. My answer is the tree is 60 what units? Well, the same units feet tall. All right, so you will put in both the number and choose the correct units. That is similarity. When the triangles are similar, the corresponding sides are proportional. All right, this one says a slow-pitch softball diamond is actually a square 60 feet on a side. How far is it from home to second base? Now this is going to use a different fact in geometry. It's not similarity any longer. This is about right triangles. Oops. Oh, I don't know what's going on with this. You can see my writing is jumping around. I don't know why it jumps. All right, right triangles. That is a triangle that has a right angle. All right, the Pythagorean relationship. If you have a right triangle, you have a right angle, I'm not sure what's going on, and you have A, B, and C. The side opposite the right angle is called the hypotenuse, and it is important that you recognize that it is a little different than the other two. The other two are called legs. And the Pythagorean theorem says that if you take leg A and square its value, and take leg B and square its value, that you will get the square of leg C. So A squared plus B squared equals C squared. All right, let's see if we can use that in our problem. Let's get a little bit more space. All right, slow pitch softball diamond is a square. The reason that's important, that tells us that every side is 60. That also tells us that every angle is a right angle, but this is what we're looking for. So let's look at just one of the triangles. Let's look at this one. Okay, we do have two, but we're just going to look at one. Which leg is C? Because which side is C? It's important to know. Well, here's the right angle. So go straight across. This side has to be C. It doesn't matter which of the two legs you call A or B. So that means that 60 squared plus, that's this one, 60 squared, that's that one, is equal to C squared. 60 squared is 3,600. 60 squared is still 3,600. That's C squared. So 7,200 is C squared. To find out what C is, we take the square root. So the square root of 7,200 is C. Now we're going to use our calculator to do that. Clear it off. On the graph, on the TI series, you're going to use the square, which is the second function of x squared, so second. Now mine has the software where it actually shows a little blinking box for the Radican. Yours may simply open parentheses, but I'm going to put 7200 in there. Then I'm going to hit enter, and I get a 84.8528. I believe that's right. And I'm not going to write any more of it. Is C, and I'm going to look back at my instructions. It says round to the nearest tenth. Now, I didn't even say anything at the beginning that this is a softball diamond. It wants to know the distance to second base, and hopefully you realize this is home, this is first, and this is second, and that's why we were finding the length of that side. All right, round to the nearest tenth. This 5 is going to tell me to round up, so it's 84.9 is the value of C, and it is measured in feet. Everything was measured in feet. That would be the distance from home base to second base. All right. I think the rest of our questions are probably going to use Pythagorean. Number 3 says a 14-foot ladder is placed against a vertical wall of a building. Okay, so we have a building. We're going to place a ladder against it with the bottom of the ladder standing on level ground 12 feet from the base. All right. This will be 12 feet. This will be my ladder. And let's see, it's a 15-foot ladder. We certainly hope that the building is perpendicular to the ground, which means that will be a right triangle. What is the question? How high up the wall does the ladder reach? This is my question mark, from the ground to right here. That's what I'm trying to find. Well, is that a leg or is that a hypotenuse? Look at the right angle. The side opposite the right angle is the hypotenuse. So if I write down a squared plus b squared equals c squared, 15 feet is c. So 15 squared goes over here. It does not matter which one you call 12. You can say A is 12, and that means I'm looking for B. All right, we have a little bit of algebra to do here. First, I'm going to square the numbers. 12 squared is 144, plus B squared is equal to 15 squared is 225. I have to get B squared by itself, so I'll subtract 144 from both sides. I get B squared is equal to 81, but I don't want to know about B squared, I want to know B. So it will be the square root of 81. Hopefully you already know, but if you don't, use your calculator. The square root of 81 is 9. So the answer is, it will be 9 feet from here to here. I'm using the Pythagorean relationship. Let's look at number 4. A rectangular garden bed measures 24 feet by 10 feet. Okay. (24 feet by 10 feet. Please just pretend that that's a nice rectangle. A water faucet is located at one corner of the garden. Okay, I'm going to let the faucet be right here. A hose will be connected to the water faucet. The hose must be long enough to reach the opposite corner of the garden bed when stretched straight. Find the required length of the hose. Okay, the hose well, I lost my whole rectangle. Okay. I was trying real hard to draw that hose in red, but it wasn't working real well for me. All right, if this is a rectangular bed, then that means that the corner is a right angle, which means that this length of hose that we're looking for is the hypotenuse. So since a squared plus b squared equals c squared, you can do it in any order. 10 squared plus 24 squared equals c squared. 10 squared is 100. 24 squared, do it on my calculator, I get 576, and that is c squared. Add them together, 676 is c squared. C is the square root of 676, so do that with my calculator, I get 26 feet. Make sure that you are comfortable taking square roots of numbers on your calculator. All right, I believe we have one more question dealing with triangles, either the Pythagorean relationship or we started with similar triangles. This one says, if construction costs are $149,000 per kilometer, find the cost of building a new road in the figure shown to the right. Okay, we have to build this road, and it is this much money per kilometer. All right, I will worry about the cost after I know how long it is. And hopefully you see that it's a right triangle. That should immediately make you think about Pythagorean relationships. And we are looking for, because it's across from the right angle, we're looking for the hypotenuse, which is c. So I start out with a squared plus b squared equals c squared. I'm going to let 4,000 be a, and 3,000 is b, and that's c squared. So I need to square both of those numbers. But I'm going to stop. I could continue the problem, but instead I'm going to say, wait. I need to know how many kilometers it is, not how many meters it is. Now these numbers are very large, and I could go ahead and do it and then switch it, but it will be easier if I remember my King Henry dances. This is meters, doubles, circles, merrily. All right, this is, and I am changing. I want to see changing from meters to kilometers. I can put all my M's on here. All right, meters to kilometers is 1, 2, 3 moves to the left. This was talked about back in chapter 9. So 4,000 meters becomes 1, 2, 3, 4 kilometers. 3,000 meters, 1, 2, 3, becomes 3 kilometers. So I can instead say this is 4 kilometers squared plus 3 kilometers squared is some square kilometers. This is 16 plus 9 is c squared. 25 is c squared. So C is the square root of 25. C is 5 kilometers. If I had continued this way, I would find out it was 5,000 meters, and then I would switch it. But whichever way I went, I need to know the length of this road in kilometers because the cost is set per kilometer. So, whoops, didn't mean to go that far. It is $149,000 per kilometer, and I'm going to multiply it by 5 kilometers. Those cancel. Multiply 5 times that, and I will get $745,000. And that's the cost of the road that is in the position of being a hypotenuse of a right triangle. So this one, a little bit of reading that we had to be cautious about because it gave us a cost per kilometer. So we didn't want to find C and leave it in meters. I went ahead and switched these, and then the whole problem was in kilometers. It just seemed easier than squaring these big numbers and having so many zeros running around my paper. So that's it with working with triangles.